Fourth grade, lesson 4.7 is divide using repeated subtraction. This lesson, we've talked about how division is equally sharing things or giving things its fair share. This one's also pointing out to you that division is repeatedly subtracting it. And that's kind of the same thing you're doing when you're sharing things. You're subtracting some for one person and then subtracting the same amount for another person and subtracting the same amount for another person. So this is just trying to get in your head that division is repeated subtraction. So let's have a look at this and then we'll look at some shortcuts for doing repeated subtraction a little faster too. Okay, and for the investigation, they have us using some counters. John is building a backyard pizza oven with an arch opening. He has 72 bricks. He will place 6 bricks at a time as he builds the oven. If he arranges the bricks in piles of 6, how many piles will he have? So you're starting with 72, and then you're dividing it into 6 bricks per pile. So what we could do is we could start with 72, begin with the 72 counters, and subtract 6 counters. So we would take 6 out, and 72 minus 6 would give us 66. Remember our borrowing skills there. And that's one time that we subtracted them. And then we'll go again. Well, so that's 6 that went out to this pile. Then we're going to do 6 to another pile. So we're subtracting 6 again. 0, 6. Then we would subtract 6 again. And we would do that over and over again until we had none left, if we could get down to none. So can we get down to none? You can continue the subtraction of 6 all the way through to see if you end up with none after you subtracted 6. And here I've done a lot of the steps for you. It goes to 54, subtract 6, 48, subtract 6, 42, subtract 6, 36, subtract 6, we're down to 30, subtract 6, then we're down to 24, then 18, then 12, then 6. And on the 12th time of subtracting 6, I get down to 0. So can I get down to 0 evenly? Yes. It took 12 subtractions. Count the number of times you subtracted 6 counters. We did that 12 times. So there are 12 piles of 6 bricks. And I know you're probably thinking, please, Miss Ann, just tell me there is an easier or shorter way to do this, because who wants to be doing this subtraction over and over and over again? And so good news is, yeah, there is, of course. This is just helping your brain recognize what's happening when you divide. It is repeated subtraction over and over again. It's the inverse or the opposite of multiplication. Multiplication is repeated addition over and over and over again. Division is the inverse, the opposite of that. It is repeated subtraction over and over and over again, or sharing equally. We shared out that 6 over and over and over again. All right, so let's look at that same thing a little bit differently and find what that shortcut is. They want us to explain the relationship between the divisor, the dividend, and the quotient, and the number of times you subtracted the divisor from the dividend. Well, we know that we subtracted the 6 12 times over, but let's have a look at that a little bit. Just so you know the vocabulary when it comes to this little algorithm that you'll be learning, the divisor is what's dividing into the dividend. So this is the entire amount that you started with. We started with 72 chips, and we are pulling 6 out at a time. We're repeatedly subtracting the 6. That's the divisor is 6. Okay. Instead of subtracting 6 over and over and over again, let's use our skills that we know, right? Well, that's 72, and so that's more than 6 times 10. 6 times 10 is 60. So I'm going to use the fact that 6 times 10 is 60 to shorten this number up a little bit. So let's go ahead over here and put 10 times 6. And 10 times 6 is 60. So I know I'm using at least 10 6s, right? Let me find out what's left out of that, though, because I need to get to 72. But I know that 10 6s is 60. So that's a big shortcut. Instead of going subtract 6, subtract 6, subtract 6, subtract 6 10 times, I'm going to go ahead and just take out that portion. And so that leaves me with 12 down here. 72 minus 60 is 12. Then I can look at 12 and say, okay, well, what times 6 equals 12? And that's going to be 2 times 6 equals 12. And 12 subtract 12, there's nothing left to worry about, right? So we're going to take the 10 from here that we did and the 2 from here. So once you put those all together, it took me 10 sixes to get that. There was still 12 left, so that's 2 more sixes. Put it all together, it was 12 times. So on this part where they're talking about explaining all of these parts, the divisor, or the dividend, I should say, the part right here, is how many chips I started with, or bricks, I guess the story was. Either way, it's what I started with. The divisor represents how many bricks in each pile. And the quotient, which normally you'll write up here. We didn't over here yet. We're getting there. But normally your quotient, that's the answer. So there was going to be 9 piles. So the quotient is the answer. In this case, it was 9 piles. I'm sorry, not 9 piles. It was 12 piles. 12 piles. Get it right, get it right, get it right. Okay. What happens if you subtract multiples of 6? Complete the example to the right. We did that already. I kind of worked ahead. What multiples did you use? We did 6 times 10 for 60. And then all we needed left was the 12. And so we did 6 times 2 for the 12 that was left. That gave us 72 taken away. Gave us a total of 12. What numbers did you add? We added the 10 plus the 2. And how did using multiples of the divisor help you? Well, it certainly made that subtraction of 6 much faster, right? We can use the skills and understanding of the numbers we know to speed things up a little bit. So yeah, that was way better than subtract 6, subtract 6, subtract 6 over and over again. So let's try several of these to get the hang of it in a practice here. And I do want to, in this lesson, go ahead and train our brains to how we write these out. So I have 84 being divided up into 7 parts. So I'm going to put 84 inside of the house looking thing. That's my dividend. My divisor is 7. That's how many pieces it's being divided up into, or how much is being subtracted over and over again. So we'll write it that way. And for now, we're not going to write anything up here, but as you get used to what's going on with our algorithm, the way we were doing in our practice, then we'll start putting numbers up here. But I don't want to do it yet because I don't want it to confuse you. I want your brain clear on what all these numbers up here mean. So I can, if I feel like it, subtract 7 over and over and over and over again until I get to 80, until I have used all 84 up. But let's just take a big, large leap and eliminate some of that. 7 times 10 is 70, and that takes out a big chunk of this 84. Not all of it, but some of it. So over here to the side, I'm going to do 7 times 10 equals 70. Okay, so if I multiply it by 10, it equals 70. 70 is what I have used up now. Let's find out what we have left. I'll subtract, find out how much is left, how much remains, and 14 is what remains. Okay. Well, 7 times what number could give me 14? 7 times what number would give me 14? 7 times 2 does. Oh, it so helps to know our multiplication facts, right? Good thing we worked on them. So now I'll take the 14 out, and look, there's nothing left. Okay, so I did 10 sevens here, and then 2 more sevens for a grand total of 12 sevens. So 84 divided by 7 equals 12. All right, let's try another one. We have 60 being divided up into 4 equal servings, or 60 being divided up with 4 going out, 4 being subtracted over and over and over again. And I could go 60 minus 4, minus 4, minus 4, minus 4 until I'm gone if I want to. Kind of miserable to do that, right? So let's use those tricks we learned. First, we're going to write this in that algorithm that we will end up using. The first number goes into the house. That is the dividend. The amount we're subtracting out over and over and over again, or the amount we're sharing it repeatedly, is 4. That is the divisor. Okay. So I would be subtracting 4 repeatedly. But let's use a shortcut. Let's take out 10 fours, because we know 10 times 4 is 40. Like, we know that it's so fast for us, right? So we will do 4 times 10 gives us 40, right? And we're using 4 because that's our divisor. We now have pulled 40 out of there. Okay, that's good. Thank you very much. So how much would be left for me to go deal with? Well, let's find out. Let's subtract to find out. 6 minus 4 is 20. Okay, so I still have 20 left to deal with. And so I need to know 4 times what number is going to give me 20. And if you know your multiplication facts, you already know that answer. If not, get on your grid and look at 4 times how many equals 20. And you will find that it's 5. 4 times 5 is 20. So I reached 20 here. So I will take that 20 out that's still there. And I have nothing left. Yay, that was my hope, that there would be nothing left. I did 10 fours and then 5 fours for a total of how many fours? Yeah, 15. I'm just going to go ahead and write that number up here. You'll get to the point where your quotient goes up here. So that together, 10 fours and 5 fours is a total of 15 fours to get us there. So the quotient is 15. It would have taken us 15 times to subtract 4 over and over and over again. We would have had to do that 15 times. Okay, let's do another one. All right, we're going to do 91 divided by 8, or repeatedly subtracting 8 over and over and over again until 91 is gone. Let's see what happens. We're going to write it as the algorithm. 91 is the dividend. It goes inside the house. 8 is the divisor, so it goes outside the house. Okay, I can subtract 8 over and over again and find out how many times I need to do that, but we already at this point are like, no thank you, I don't want to do that. We're going to do 8 times what number to get to 91? Well, I know my tens, and I know that's 8 times 10 is 80, so this is even higher than that, so why not just get those out of the way? 8 times 10 is 80, so I'm going to put, I've used up 80 by doing this. I'll put it there. How much will I have left? 1 and 1. I'll have 11 left, and so that was 10 eighths being subtracted, right? I'm going to keep getting that backwards. 10 eighths being subtracted. Okay, now I'm going to subtract 8 again, but 8 times 1 is 8, and 8 times 2 is 16, and neither of those are 11, right? So, okay, but the goal is you get as close to having them gone as possible without going negative. We can't go negative. So I can do 8 times 1 is 8. There will still be a few left, but there is not 16 to get rid of here, so I can't go that high. So I'm going to cross this guy out. No thank you. Okay, and I'll use this one. I have 8 times 1 is 8, so now I take 8 of those away, and 11 minus 8 is 3. I used one more 8 to get there, so I have 10 eighths and then one more 8 for a grand total of 11 eighths. I'll write it up here. I ended up having 3 left. Remember in the beginning of the chapter they talked about remainders? So we can just put remainder 3. They also talked about putting that as a fraction. We could put 11 as the quotient with 3 out of the 8 remaining. So either of these is fine. That's how you would write those. Sometimes there's some left. As long as what you have left isn't larger than your divisor, you're okay. If this number was larger than your divisor, then you could have kept subtracting, and we didn't. So this number always has to be, when you're like, oh, I'm done, can't do any more, this number needs to be smaller than your divisor. So always check for that. Okay, we'll do one more practice one. Hopefully that's enough. If not, I can help you more in class. We're going to do 65 divided by 5, or 65, and we're subtracting 5 from it over and over and over again until it's gone. Let's write it as the algorithm. This one you might want to pause and try, see where you get stuck. I have 65 as my dividend, 5 as my divisor. 65 is more than 50, and I know 5 times 10 is 50, so I'm going to go 5 times 10 equals 50, and I'll take that 50 out of here to see what's left. Subtract. Okay. Now I have 5 times something is going to give me 15, or as close to it as possible. Well, 5 times 3 is 15. Oh, okay, how handy is that? That gives me 15, and looky there, nothing's left. Oh, so it divides in perfectly. That's nice. I needed 10 5s here and 3 more 5s to get there for a grand total of 13 5s. So there's my answer. Hopefully that makes pretty good sense to you, and you can move forward with it into Think Central, but let me know if you need extra practice.